Let's do this proposition 1.9. This is from the book of Mathematica, Commutative Algebra. Let's do this as exercise. This is saying element is in the Nilradical. Okay, so this is the Nilradical. Sorry, Jacobson radical. Jacobson radical, which is the intersection of the maximal ideal of a ring A. If and only if 1 minus x times y is a unit in that ring for any let's prove this, okay, as exercise. So because this is a very widely used statement or fact, basically what it is saying, you see this kind of, so the statement here is kind of saying that one and how big is this ideal, right? It's telling you some information about this ideal generated by element in the Jacobson ideal. You got element x in the intersection of the maximal ideals. If you look at the ideal generated by x, right? Obviously this is not the whole ring because it's containing maximal ideal, but so this is stupid, okay? This is stupid. This is stupid. I'm not really requiring this, but I'm saying that element of the form identity minus any element from this ideal, which means minus, it doesn't matter here is minus or plus, it doesn't matter, right? Because this is also 1 plus x times minus y. Y doesn't matter, plus any element from this ideal. This is a unit. This is a unit. Well, in general, we don't know element plus unit is unit or not, but we know nilpotent element plus unit is unit, right? We know that. But this is not yet a nilpotent element because the intersection of the maximal ideals contains the intersection of all the prime ideals, and this is the Nilradical. And we know that in this case, if you pick element here, then this will be unit. But this tells you that already if you pick element here, It is also true. Right, in particular. Because whatever but the converse direction, what can we say? Surely this statement repeats this if and only if this will not be true, which means this is contains the Nilradical. Okay. So surely if your Nilradical is still 1 minus xy would be a unit. That's very trivially true. Okay. But we know that the converse must not be true for Nilradical, but only true for Jacobson rad, which means if 1 plus z is a unit for any element generated by x, then xc we don't know it's nilpotent or not, but we know for sure it's in the maximum ideal. I mean, this statement of proof of this would not be difficult, but sometimes it's confusing you to find a way to remember it, for myself at least. So let's see the proof. So let's first prove this. If you got an element in this Nilradical, then we want to prove that 1 minus xy is a unit, because if not, then it's containing some maximum ideal, right? Containing some maximum ideal. But if this is containing some maximum ideal and x is also containing all the maximum ideal, in particular the same maximum ideal, so I imply that 1 is containing this maximum ideal. That would be contradiction. I mean, the proof is okay, but the proof itself doesn't help me to remember the statement, you see. Let me ask. Yes. So, easier proof, or obvious, more obvious proof is for implies 1 minus xy, 1 plus, doesn't matter, this is plus or minus, doesn't matter, right? Is in the unit. This is our exercise. This is exercise 1 actually. But we know that, okay, so this property very nice, but to have this is not necessarily this is nilpotent, but to have 1 plus xy, it suffices x is in the Nilradical, but not necessary. Actually, is equivalent to X is in the intersection of the maximum ideals. This is what is theorem telling us, right? Okay, let's prove the other direction. The other direction is, suppose this is the case, then we want to prove X is in the maximum ideal. So suppose not in the intersection of the maximum. Suppose there exists some M. X is not there. So X and M generate the whole ideal, which means X times Y plus some element in this maximum ideal equals 1. We want to show that there is some contradiction, right? The contradiction comes from then this small m equal, but this is a unit, and this is a contradiction. Let me call this exercise 4.